Welcome back. Let's get straight into it as we are looking at using the table of standard reduction potentials to do various calculations with galvanic cells. We've already seen how we can use the table to write net reactions, but the calculation of the E0 value is something that I think we need to spend a little bit more time at, and the way that we're going to do it is by answering a question. So let's go and have a look at our question. So it says to us, which combinations of half cells will give the biggest reading on the voltmeter? So the E0 of the magnesium zinc cell was 1,61 volts. I wonder if the iodine chlorine cell could give us a bigger E0 value. Well, I don't know. Let's go and see. So what you can see here is we've written down the reactions, not on the table, because sometimes that's exactly what they do in a question in an exam. And we have to look carefully at not expecting to learn all the values. In fact, they could have given us an equation that doesn't appear on their table, but gives us the E0 values for that reaction. And what you've got to be able to then do is identify which one is the reducing agent and which is the oxidizing agent. And how do we do that? Well, you should remember that the reducing agent is going to be closer to zero, or the more negative one of these two values, because both of these are positive. And so you might think, oh, nothing's going to happen. No, we're going to have to find the one that is closer to zero, that's the more negative. And that's the one that is the more negative. So you have to check this and make sure that you understand that the iodide ion is going to be the reducing agent. Now, it doesn't look like what we've done previously, because iodide ion is a non-metal, but it's the reducing agent, and it's therefore going to undergo oxidation. And so we would need to see that the iodide ion in this process is actually the anode. It's kind of different because when we were dealing with metals, the anode was where ions formed. Here we're dealing with non-metals, and the ions aren't going to form, but the metal, the element, is going to form. The non-metal, the element iodine, is going to form. So in this cell, we are going to need to rewrite the equation and turn it around and say that it goes 2I minus, which is an aqueous solution, going to form I2 plus 2 electrons. And then what's going to happen in the chlorine gas? This, notice, is a gas electrode, so the chlorine is going to gain the electrons, and so chlorine is going to gain electrons to form the chloride ion, which is aqueous. Notice that that's a reduction reaction, so this is the cathode. So if we're going to do our E0 of the cell calculation, then we're going to say, remember, let's take E0 of the cathode minus E0 of the anode. But there's the other equation that's on the data sheet, which says instead of the cathode, what we're going to do is we're going to say, let's take the E0 of the oxidizing agent. Now, if you're not sure, you can check and write both down and make sure that you've got it, minus the E0 of the reducing agent. The reducing agent is on the right-hand side. So we're going to make sure that we get that right. We're going to write down the oxidizing agent, first of all, as 1.36, and it's positive, minus, And then in brackets, we're going to put the anode or the reducing agent, and we're going to say 0.54. Now, we didn't have to have brackets because there was no negative there, but let's get the calculator out and just put those values in. 1.36 minus 0.54. And what we find is that the answer here is 0.82. So 0.82 volts. Again, notice that it's a positive value. So it is still a spontaneous reaction. It will generate some potential difference, but it's not as much as the magnesium zinc cell. Please don't let that give you the impression that metals are always better than non-metals. It's not always true. We can pick a whole range of non-metals, half cells, that will give you as big a potential as the metals. And in fact, choosing the biggest ones apart is going to give you the most overall. So to answer our question, which one is the biggest? This one was the E naught of the cell, was 0.8. Let me just check the answer there that we got, 0.82. So quite clearly, this one is the better, is going to deliver the better E naught value. So absolutely important to do these calculations and to be able to see how valuable this table is that you're going to take into the exam. It's like having extra help. So make sure you're comfortable with it, that you identify all the values from it. And you know what? There's one other thing that I've learned over time, is sometimes people forget the polyatomic ions. And the polyatomic ions are on this half reaction sheet. So you can pick out what the charge of a sulfate is or a nitrate is. They're on there. Go and have a look for them. Let's just summarize what we've learned so far. And as we've been talking about the galvanic cell, remember it transforms chemical potential energy into electrical potential energy. The E naught of the cell is comparing a half cell to the standard hydrogen half cell under standard conditions. So it's telling you how much energy is being converted. That's what potential differences. It's the work done, energy per unit charge. And so it's a very good reading for that. Also note this, that oxidation always takes place at the anode. The reducing agent has the more negative E naught value, E naught of the cell value, compared to the hydrogen standard electrode. Of course, that tells us that the reduction takes place at the cathode, so the oxidizing agent has the more positive value. And when we combined an anode and a cathode, the half cells together, and we get a positive value, we know that reaction is spontaneous. So I hope you recognize that we've covered many aspects of the galvanic cell. And so just make sure that you've got all of those ideas clear in your mind. The galvanic cell is related to the redox reactions, that there are reactions at the anode is oxidation, and at the cathode is reduction. That there is a salt bridge, and the function of the salt bridge is important, that you can write cell notation, and you recognize this standard reduction potential all relates to the standard hydrogen electrode. Let's just summarize some details of the galvanic cell. Please remember the galvanic cell transforms chemical potential into electrical potential, and that is indicated by the E naught of the cell. Also, that oxidation takes place at the anode, very important to remember that, and that because of that, the anode is going to be the one that has the most negative E naught. Similarly, reduction takes place at the cathode, and this is going to be the more positive E naught value. Guys, I hope you've enjoyed being with me. I have really enjoyed this lesson, and I hope you excel at galvanic cells. We'll see you again soon.